Hello everyone, and welcome back to my BPHO video series. In this video, we are going to look at question 1G from the 2018 British Physics Olympiad. Let's dive in. First, let's read the question. A uniform chain with mass per unit length, denoted by the Greek letter mu, is suspended from one end above a table, with its lower end just touching the surface. The chain is released, falls, and comes to rest on the table without bouncing. Part 1. Determine an expression in terms of mu and the gravitational field strength G for the reaction force exerted by the table on the chain as a function of time t. Part 2. In terms of the total weight, W, of the chain, what is the maximum reaction force exerted by the table, and at what time during the fall does this occur? Starting with part 1, let's assume the chain falls freely from rest. At any time t, the speed of the falling chain is g multiplied by t. The length of the chain that has landed by this time is equal to 1/2 gt squared, using the standard kinematic equation. Now, let's examine the reaction force from the table. This reaction force has two components. The first component, R1, comes from the weight of the chain already on the table. The mass that has landed is μL, and weight is mass times g, so R1 equals mu times L times g, simplifying to 1/2 mu g squared t squared. The second component, R2, comes from the momentum change of the chain as it hits the table and comes to rest. We imagine a very small portion of the chain, a length we called delta x, hitting the table during a tiny time interval delta t. From the hint, the impact force is given by force equals delta m over delta t multiplied by the velocity. Now, delta m, the small mass arriving, is equal to mu times delta x. Plugging in this into the force formula, we get mu times delta x over delta t times v. Since delta x over delta t is the velocity at this moment, so R2 equals mu times v squared, which is mu g squared t squared. Now, adding both components together, the reaction force R is equal to 3/2 mu g squared t squared. Moving on to part 2, let's say the total length of the chain is L. We want to find the maximum reaction force, which will happen right at the end of the fall, when the last bit of the chain hits the table. From our earlier kinematic equation, the time it takes for the entire chain to fall is the square root of 2L over g. Substituting this into our expression for reaction force. Reaction force equals 3/2 times mu times g squared times t squared. Plugging in t equals square root of 2L over g. So reaction force becomes 3/2 times mu times g squared times 2L over g, which equals 3 times mu times g times L. Since mu times L times g is simply the weight of the entire chain, W, so the maximum reaction force is 3 times W, and it occurs at t equals the square root of 2L over g. That's it for the question. Thanks for watching. I'm Physics Michael, and I will see you in the next video.